Drop by.
Thinking about it. By golly, you should drop by this program. Hello, everybody. My name's Ronnie Heron. I'm your regular host for Santa Barbara Astronomical Unit's weekly vlog podcast called the SBAU Astro Hour. This is number 285 for August the 10th through the 16th, 2026. It's all about the cosmos, honey. Since there's a lot of it out there and a lot going on. Our club's been meeting up at the Santa Barbara Museum of Natural History for decades. For our first Friday membership get-togethers, our second Saturday star parties, and even on Sundays, we look at the sun through the Palmer Observatory scopes. In fact, it all happened this past weekend. We're going to have another one like that opening up the new year coming up in a few months. So check us out online, please, sbau.org, and welcome aboard. Let's check the celestial topics of this week. It's a follow-up, to our recent updates on SETI and our club's President Friday Night Talk on possible life-bearing exoplanets. We're going to introduce you to a super Earth about 48 light years away. As far as our own sun's planets, well, we'll round them up for you in the night sky. Building on the success of NASA's little Ingenuity Mars helicopter years ago, we're now ready to launch Skyfall, a mission from NASA that's going to send 3 rotorcraft to the red planet in 28. It's a good time to catch Comet 10P Temple. And we're going to focus on a planetary nebula called the Little Gem, along with a great lizard in the sky near the constellation Lacerda. And of course, this week's meteor shower, the dreaded Perseus. Let's meet the crew of the ship, shall we? Here he is, our president, who becomes our Monday morning quarterback, Professor Jerry Wilson. You did good Friday night.
I'm not a professor.
Oh, you are for this.
Good morning. Good morning. My sister Joyce, my grandkids Riley and Calvin, and my wife Pat.
My Pat is our first lady. Ducked her head in earlier, and she missed your speech on Friday, but you can see it played back, I'm sure. Here's Captain Outreach on the right side of my screen, man who takes us everywhere, Chuck McPartland. About to get some new tools for the club. And how's your wife, Pat, our treasurer merch manager?
She's doing fine.
She's doing good. How many cats? Yeah.
Just two. Yeah.
2 in McPartland Manor. Okay, in order of joining us, here's the other speaker for Friday, the 4th of December this year, the in-house members meeting. It's Jim Crawford.
Oh, hello.
Very declared. And is in front of what, Ireland's coast, I guess?
That is, come on, we've discussed this many times. That's out there at Hollister Ranch.
Really? Does it look like it?
Yeah.
Looks like Irish. Okay. Here's a man with a photo of a flower behind him, and he spent years teaching science out at Westmont, and he's been editing our newsletter for years. Tom Whittemore.
Yeah. Morning, everybody.
Former Westmont guy who's married to Maureen, and Tim is married to Karen. And we do the sillies every week on this program, which hooks a lot of people. So let's get to the forwarded silly science cartoons from President Jerry. There's Einstein. Did he really say that? I'll let you start out, Mr. Prez.
He did. I have heard this from when I was a freshman or even in high school in the early 60s. I was laying out in my front yard on the lawn with my brand new transistor radio in 1955 when they announced that Professor Einstein had died.
Yeah.
And I was very shocked. But I had heard this phrase. I attributed to Albert Einstein. I don't know if it's true. I believe it is. I've heard it often enough. So, and it sounds like, I don't know what it sounds like. So anyway, 2 things are infinite: the universe and human stupidity. And I'm not sure about the universe.
There's a quote over the observatory door at Palmer that's attributed to Carl Sagan that actually isn't something that he said. So we might want to tell Isla about that.
Okay.
It gets a lot of comments, Chuck.
Yeah.
People really like that. Yeah.
What is it?
It's somewhere out there, something incredible is waiting to be discovered.
Right.
Something like that.
Yeah.
Okay, well, is this washed out, or is there enough we can see here?
That's enough.
Okay. I can take the hint.
Oh, no, that's good enough.
It's okay.
I think that's the one about the ancient view of the Big Dipper or the bear or Ursa. Let's see if I can
Ursa
remember.
Major?
Uh-huh. Dipper was just a spoon back then, maybe. Ah. Okay, Chuck, you want to guide us through this? What are we looking at here?
Well, you've got a hiker and he's encountered a bear. And one of the things they say is if you bump into a bear when you're out hiking, try to make yourself look big. Actually, I think that's what you try to do with a mountain lion.
That's right.
With a bear, you're supposed to just be kind of passive. But anyway, and he says, the hiker says, I went to Oxford, I drive a BMW 440, and I have my own podcast. So he's trying to make himself look big.
Right, okay, guy.
And the bear does not look impressed.
No, more curious.
Okay, any engineer on the screen want to take this on? This is definitely a diagram on the life of engineers. There's a dip involved. But Jerry?
Okay, this is a graph of basic science skills. And the axis down here is primary school, secondary school, university, and work. And you first do numbers, then basic operations, then geometry, then they have trig, algebra, then trigonometry, then calculus, then you get into physics, and then you go to work and you're using Excel.
I've often wondered about the definition of an engineer.
Yeah.
Is it sort of a machinist for science?
Yeah. Do you see the one on the top, Jerry? The limit n goes to infinity. Do you see that one on the very top?
Here?
To the left, just to the left.
To the left. Do you know what that is?
Oh, yeah.
What is it?
Infinity?
Naperian base.
I know the one on the top right.
It's the Naperian base. It's the number.
Wow.
2.1828, then it goes.
Yeah, E.
Yeah. Naperian base. Yeah.
Yeah, and not to be confused with this E.
Right.
Yeah.
So when I was working, I didn't use Excel for math. I used MathCAD, and I did use Excel on occasion, and other forms of writing code, mostly in Fortran. But I was talking with the company that made Excel, MathCAD, and they said that they had done a marketing survey and that 15% of engineers employed in aerospace actually did math as part of their job.
Yeah.
Yeah.
Really?
Yeah.
But you build everything, right?
Mm-hmm.
Well, one time in high school, a teacher told me, he said, you'll find there are two types of engineers. There are engineers that work in the lab and build things. And then there are engineers that spend time thumbing through catalogs.
Well, this looks like the old buckets on the table physics problem that I have no idea. Who wants to tackle this? Raise your hand.
Not me.
Jerry, Chuck? Are they
Well-
not being held up by cords on the table?
Yeah.
Yeah.
The cord goes from this bucket up to that pulley and down to the center of this table. Now, these things are all balanced here, so there's equal weight on each corner. And the gravity pulling this down is countered by having to lift their own weight.
Oh,
So it's
there
just
you
as
go.
if this cord goes up and comes straight down to this, except that it has to transfer through the table, so it is used here to keep the table up too. It just takes a moment's reflection to see that it's not mysterious and defying gravity.
Yeah, when I first saw this, I really thought that, are there suction cups on the bottom of the bucket? Because how's it, but it's lifted by its own weight. That's interesting.
Yeah.
And you could overfill the buckets and still get away with it.
Yeah.
Here's our weekly bubblehead stick figure dialogue about Antique Roadshow, PBS, if it involves celestial objects. I'll tell you what, Tom Whittemore, you want to guide us through this? What are we talking about here?
I'll do my best. So now your grandmother said this was a relic, low mass population 3-star, from the first generation of stars. Unfortunately, the high iron content shows that it formed much later, after several rounds of supernovas. I'm afraid it's a population 1 star. Oh,
And he
darn.
says,
Yeah. Oh, darn. Well, it still has sentimental value.
okay,
So this is the Antiques Roadshow, which if you're a fan of on TV, people
Yeah.
bring in all sorts of junk from their house to have it evaluated. And every now and then someone has a Van Gogh or something, but mostly it's just cheap copies, and they go away saying, well, it has sentimental value.
so there's value in the stars.
Right. So population 3 stars is one of those things in astronomy where they named it before they knew it. And so population 1 stars are the most recent population of stars you see in the sky. Population 2 stars are much earlier stars, but still have metals in them. And population 1 stars, excuse me, I went the other way. Population 1 star is the one you see in the sky. Population 2 stars is earlier than that. And population 3 stars are the very, very first generation of stars, which have no metallicity in them. They just are hydrogen and a little helium. And that's why, because of the iron content, it has to be a population 1 star.
And our sun is a population 1, right?
Yes.
Yeah.
Okay, Mr. Crawford, you want to read this and interpret it for us?
This one, I'm a little bit
Oh, okay.
confused by. It says it's only physics if it's from the physique region of France. Otherwise, it's just sparkling math. So I guess what they're doing is crossing physics with champagne.
Yeah.
Perrier water, I think, isn't it? Early astronomy, Jerry, what are we looking at here? Ancient.
Well, there he goes again, pushing the whole medium dipper thing.
I like that.
They didn't have it big enough back then, huh? Okay.
I like that one.
Okay, well, let's try Chuck on this one.
Okay, well, there's a couple of stranded people on a desert island, and you can see a sinking ship on the left and a sinking spacecraft on the right. And the human is kind of sitting there, and the alien is saying, "Stop whining. You're 99.9999999% closer to home than I am."
And this rocket is about to go to the UFO, now known as UAP.
What's the thing in between them? That's what I didn't get that on the in the sand. I guess a sundial?
No, it's a palm tree.
No, the one down on the ground. It looked like it was
Oh.
he was using it as a sundial, I think.
Oh, that's just his toe sticking up.
Oh,
Oh, well. Okay, we're about ready to show you the night sky, I got a feeling. We'll see what
Yep.
happens. Let's get into the program, ladies and gentlemen. Number 285, the Astro Hour.
Okay, this is a very hokey finder chart in Cetus down here. And this is a red dwarf star with a planet. See the B, it's LHS 1140 around it. And I saw this just the day after I gave a talk about how you're not going to find planets with atmospheres around red dwarf stars, most likely. And here we have a planet with an atmosphere around a red dwarf star that was just discovered. Now it's a giant planet. And we were talking about rocky planets before, but this is the region where it is.
I like, oh, okay.
Go ahead.
You see that there are labels on some of the stars. So there's Fomalhaut.
Yeah. Yeah,
Well, this is
down
a
here.
different one. This is a different one. If you go back to that original one.
There you are.
Okay, so there's Difta, that's also known as Deneb Kaitos, the tail of the whale. And you have M77, a Messier object. You have Fornax, which is a whole constellation. So it's kind of weird the way things are labeled. And then there's M30, another Messier object. And then you have Pisces Austrinus, another constellation with Fomalhaut. And then you have Sol up at the top, and that's the name of our son, and that doesn't seem to make sense to me.
Oh. That's why, since they went to the trouble of putting the target in the correct location around Cetus, like here, that's why I put this in.
Uh-huh.
So it makes sense. I've got this one too.
Okay.
So you see up here is Neptune and Saturn, and so I don't know what Sol is supposed to mean in it, but right in here is where that exoplanet is.
Oh, I got you. Yeah, now I get it.
And
Is
this
the
is
only one?
4 in the morning.
Is it part of many, or is it the only one around the star?
This is just I don't know. I think that this is just a single star that they've isolated and looked at.
Didn't you send us a picture of a comparison in size with Earth?
No.
I think I saw something. It's bigger than us.
Yeah,
Yes,
it's
it's
a
a
super Earth.
Jupiter-sized planet. Now, this is a little tricky. You have to look at the caption in the talking points for the words. But this is the star, LHS 1140, and this is their distance, the distance of the planets. This is a red dwarf, so everything's going to be closer in than this. And this is the LHS 1140b, but it's got the color of a snow line. So we have, I've got to get rid of that. So this is 1/10 of an AU. So Earth is this little line right there. So the Earth is 10 times farther out than this. So this is in actually, all this activity is closer than Mercury to our sun. And it's in kind of that, it's scaled to show that. The snow line is where you don't get liquid water. That's where you get ice from there on out. And the inner B and the outer B is the
Goldilocks zone.
yeah, thank you, Goldilocks zone. And the planet, I don't think I have a picture of that. Wait a second, it's
I thought I saw one.
There was yeah, there you go.
There you
Yeah,
go.
there it is.
now what does happen with these cases, here's the size of that planet, and here's Earth in comparison. And what happens with this orbits around the planet or around the sun in 24.7 days. So it's very close. It's moving very fast, and it's a very big star. So it has an ice surface. It's tidally locked to the sun is where I'm going. And so it always has the same face to the sun. And so any heat it gets is going to just melt the ice on most of the planet. And it's going to be water around here and then liquid in this region right under the sun at the nadir point. This is if it's a solid ice body, but they can't see the difference between these two, but the claim is made because of where it is on the previous diagram that this is a candidate for what they call eyeball planets. And this would be what that looks like.
Wow.
It's not a good place to mimic the evolution of life on our planet.
And
Conditions.
it was on the green orbit.
What's that?
It was which orbit of the colors you just showed? Right there in the middle on the green, or was it further out? Okay, it was further out. It was extreme right, the purple, or the there it is. Okay.
Yeah, there's the snow line.
So I think the planet is meant to be the dot that's on the line there.
Yeah, that's my feeling too.
Huh.
The snow line would be if it's a rotating planet, it would be completely ice covered out here, but it's not. It's locked to the star. So part of it will be melted, I believe, and that's where they get the idea that it's going to be an eyeball planet.
But since that's a red dwarf, we're looking at every one of those planets getting bathed in flares and precipitous.
The comment was made in the research paper that this is an unusually calm red giant star.
Red dwarf.
red dwarf, excuse me, yes. So that's almost of no interest, but the planet does have a tail of hydrogen that it puts out into the, so there is a solar wind or a stellar wind that is blowing its atmosphere away. It's just that being a big planet with a strong gravitational field, it's just taking a lot longer to blow the hydrogen atmosphere away.
And I think it was helium they detected, not hydrogen.
That's right. You're right. Yep.
Well, I
I
would
see I've
think,
got-
gentlemen, it'd be easier to focus on planets around a red dwarf because it'd be easier to filter that smaller star than the big bright suckers that are.
But then they're closer. They're closer, Ronnie. The planets are closer to be in a habitable zone.
And
Yeah.
then we don't see those stars with naked eye, right? We gotta use a telescope to even make them appear.
Right.
They are faint, and you don't see them far away in our galaxy.
It sounds like their year is our month.
Yeah.
Yeah,
That's about right. Yeah, 27,
24 days.
24.7 days.
that's for the outer one, right? The one we're looking at. The inner ones probably go by even quicker, don't they?
There, yeah, but there isn't an inner one in this case. There's just the one.
Okay, so those are on the green and the red inner orbits. They don't think
There
have
is an LHS 1140C planet. There is
Okay.
another planet,
So there's two.
but it's not indicated on here.
So right now, Ronnie, we would be about 32,000 years old.
Yeah.
Thanks. I felt old already.
Wow.
Okay, planets, our own Earth's, our own solar system here. This is the pre-dawn sky, post-dawn. Yeah, this is dawn, about to be, it's early dawn. I just did it to fit Uranus and Mars on the same chart. This is the morning sky looking east at about 4:30 in the morning here. Our skyline from my house does not look like this. This is just the default one in the Sky 6. And we can see that Orion is rising, and it's going to be overhead in the evening 6 months from now. This is a little later in the morning. This is 6:30. Sky's not going to be this dark.
No, this would all be blotted out.
Yeah. So you can see the sun is right about here. It's about to come up. If you're really careful, but I wouldn't give it a shot. Jupiter is down here. The moon, crescent moon,
The moon was easy to see, Jerry, this morning.
Okay.
But more like 4:30, something like that.
Yeah, this is tomorrow morning. So, and there's Mercury right next to it. So the moon is probably about here this morning, right? Yeah. Okay. And there's Gemini. Now around midnight, we catch the two easy planets, Neptune and Saturn. And Saturn is near opposition. So it's going to be a big planet, a relatively large angular extent. And it's a big planet, so you should get some good views of it. But it's just
not
right
near opposition
you
yet.
don't see it.
Not yet.
Yeah.
What's that?
Saturn isn't near opposition yet.
Right.
Okay. But it's getting there.
Yeah, it's heading towards it.
Yeah. So here it is at midnight rising. Oh yeah, it's got months to go. Okay. So around, if it's here at midnight, then it'll set about noon, before noon.
Yeah.
Yeah, so okay. And then this is the evening sky. Sun is down here and Venus is over here. Very prominent. One of the widest separations from the sun we'll see. It's very bright, and it's at what would be in the moon last quarter or first quarter, I don't know which. But in Venus, it's called dichotomy, which means that it's how it appears from Earth.
It looks like first quarter if you don't have a diagonal and third quarter if you have a diagonal.
Right. So here we are. This is, you read this chart this way in the evening sky, July 1st, August 1st, elongation east. That's August 15. So that's 5 days away. And you can see it's exactly half the disk is illuminated and half isn't. Here it's shifting toward concave, for crescent. It'll be this really big dynamic crescent if you can catch it there. And sometimes you can see the edges of this crescent starting to go around the disk farther than what you'd see on the moon because there's an atmosphere that's refracting some of the light.
And
So
Andy said he's going to try to image Venus all the way to the big crescent phase, even though it's going to be low on the horizon.
Yeah.
Can any of you guys explain to me in less than a minute what the rotation time, what does Venus get, a day in our year, or is it going opposite?
You were about right with your guess.
Am I right with my guess? So one day lasts a year on Venus?
I think the year on Venus lasts longer than, or the day lasts longer than the year.
Yeah, the year's about 9 months.
What's going on? Is it turning the same direction we're turning or going opposite?
No, it's been flipped.
Yeah, it's retrograde. So that is a big question in astronomy. What happened to Venus? People refer to the early solar system here as a shooting gallery with so many objects around. It hadn't stabilized on the orbits we have now, which are all in harmony with each other, more or less. And although nothing's infinitely stable. So probably it got hit like the Earth got hit, but it didn't have the same result of knocking off the crust of Venus and giving it a big moon. It just changed its rotation rate to almost nil. It did affect our rotation rate too. It gave us eventually the day we have. And it's also believed that, which is the one, Uranus, is also possibly the result of a collision with an older planet because it is tipped so that it looks like it's actually rolling around its orbit. We part of Uranus's year, we're looking down on its north pole, and a year later, half of its year later, you're looking at its south pole.
Well, I got to tell you, a recent PBS Nova series actually explained to me how Jupiter came in billions of years ago and affected us, came in close and then went back. I can't remember what the explanation was, but it made sense. Probably a passing star or something.
Yeah, I've heard Jupiter referred to as our left guard. It gravitationally disrupted a lot of the orbits of early things that would have hit the Earth or the things. So it basically sacrificed itself for cleaning out the planets and large asteroids from our solar system.
Yeah, that whole sequence. Go ahead, Tom.
Oh, I just to say for our well-being, huh?
Yeah. That's called the Nice theory or whatever. They did simulations to try to explain the orbits and especially the dynamics of things that got tossed out by Jupiter that you see that are still in these hugely elliptical orbits. And so they called it the grand tack, where there was still a lot of junk in the plane of the solar system. So it acted like a viscous fluid and it kind of and then there was enough stuff interior to Jupiter that the mass pulled it in, and Jupiter came in about to the orbit of Mars and threw out a bunch of stuff and also threw a bunch of stuff in. So we got bombarded with a bunch of stuff. And then Saturn formed farther out, and plus it had been thinned out by Jupiter's passage, and so now it didn't have that viscosity and it drew it back out. So it's called the grand tack.
Well, I've heard our solar system described as Jupiter plus a lot of debris,
Yep.
The
plus the
Grand
sun, of
what,
course.
Chuck? The Grand, what was the last word?
Grand tack.
Tack.
Like a sailboat going against the current.
Oh, okay. Okay.
Okay.
Skyfall.
Next is NASA's next mission, going to be launched in about 2 years, possibly, called Skyfall. And it's built on the Ingenuity helicopter. The next probe to there is going to not land a rover, it's going to land with 3 helicopters on it, and it's going to release the helicopters in mid-flight before it gets to the ground.
So they won't have a mothership to send back the signals?
No, the ship that carried them down, I believe, is going to crash into the
So they'll
surface.
they'll have to have their own radios beaming to Earth.
Okay.
28.
Optical cameras, visible near infrared, ground penetrating radar. That's the major new thing here. Temperature sensors and radiation monitor. They're just the same size as the Ingenuity. They're 20 inches tall, about 11 pounds. They weigh about what my cat does. Although my cat's been eating very well now that she's been locked up in her room due to our construction here. So she's probably over 11 pounds now. Let's see, rotor blades, 2 counter rotating, same deal. This is from AeroVironment of Arlington, Virginia. And I guess discussing the word will in here means it hasn't been designed and manufactured yet. So
That's interesting that they're using a nuclear reactor and they're going to crash it into Mars. They kind of don't mention that.
yeah.
Well, Jerry, do you
Yes.
suppose your godson might have a job again?
Oh, well, he's got a job now. So
But he's not going to fly one of these.
he works at JPL, and
I know, but
he was the pilot on the last helicopter.
right.
Oh, don't confuse it with a pilot that runs things in real time. It was a mapping and thing, and then they download the course into the machine.
I wonder if they plan to fly all 3 at once.
Yes.
They do.
Do they really?
Yeah.
Different areas. Wow.
So this is the Freedom Flight, Space Reactor 1. Oh, this is the ship to get there. So this is a late 28. Go ahead.
Oh, no, never mind. I thought I saw that it was going to do a second flyby after releasing. So it's releasing a capsule that will release the Skyfall. So they're not going to crash the nuclear reactor into Mars, I hope.
I think the nuclear reactor is going to be on each helicopter.
No. They couldn't do that.
Well, that's a little confusing because they're kind of heavy.
Yeah.
They can't support a what's the solar panel?
Yeah, they have a solar panel on the top.
Oh, they do. Okay.
Yeah.
But how did the last one work with Ingenuity?
It had a solar panel on the top.
Yes, it did, but did it have to go back to the mothership to get recharged periodically?
No.
It just stayed there. Okay. So this is going to be exactly the same thing. So maybe the thing that delivered is going to land.
No. It's okay. So the space reactor Freedom is going to go by and drop a capsule that has the 3 helicopters in it, and that capsule will deploy the helicopters.
Okay.
But the spacecraft itself is not going to crash. The nuclear reactor is not going to crash into Mars. So I was wondering why they weren't mentioning that.
And the 3 choppers will go different
Yeah,
areas
conduct
of Mars.
second Mars flyby and transmit imagery back to Earth. So they're not going to lose that.
Yeah.
Oh, and then the capsule. Okay.
The capsule is the Skyfall capsule.
Yeah. Okay. So this is its mission, surface mapping. And the new thing on it is a ground penetrating radar and visible light imagery. These are all pretty much the same as the other one. advanced meteorology, radiation monitoring, and atmospheric dynamics means they're going to try and figure out which way the wind is blowing.
Yeah. The subsurface mapping with the ground penetrating radar, that probably takes more electricity. So yeah, they must have heftier solar panels.
Yeah, this is a picture of the thing with the penetrating radar antenna stowed. So it looks like it's a flexible piece of plastic or something. And then here it's deployed, so they unclip it and let it fall down. And then it sends its radar down and sees what's down there, looking for pirate treasure.
Yeah.
And oh, there's the solar panel on top. Okay.
Hmm.
Huh. Interesting.
Okay. Now we're looking at not Pluto, despite what I said on Friday. The purpose here, just look at my notes here, Mercury.
This is near where the comet will be.
Yeah, that's what we're leading up to. Deep sky viewing under moonless skies,
Hmm.
Comet Temple and Messier 30. And so this is from Messier 30
Oh.
Yeah, up near Capricorn.
right there.
Mhm.
And then we do a star hop, which is not shown here. It's on a Chuck diagram.
Oh God.
But you can see M30 up here.
Mhm.
So it goes right down here on a very slight S curve, very almost a straight line. Down here past Beta Aquarius. So here we have, oh, it's going up. So there's M30, so it's going up. I think SCAT is the Beta Aquarius.
It's actually going down. It's
Mm.
going to be down in Pisces Austrinus. I wonder if that was Beta Pisces Austrinus.
Oh, that could be too. Yeah, that would make more sense. But it doesn't show Fomolo up there.
No pictures of the comet?
No.
Hmm.
And there's another one in the morning sky, Comet McNaught, that has gone through an outburst and gotten quite a bit brighter too.
Mm.
Well, what's the story on this one? How many years in its orbit? How often do we see it?
Um,
It's a short, relatively short period comet.
mhm. You're right. It's Beta Pisces Austrinus.
Okay.
Whatever it is. Pisces Austrinus, yeah. Hmm. Okay, I didn't have space to put in a lot of detail on Comet Temple,
I
but
think it's on the order of 10 years or something like that.
Whoops.
Well, that would not put it out of the Kuiper belt. Wouldn't have time to get back there. And
Right. It's a short period comet.
is it based in the asteroid belt between Mars and Jupiter?
No, well, it may be, yeah, with an orbit like that, because Jupiter's 12 years.
Mhm.
So comets come out of the asteroid belt.
No, it probably came from the Kuiper belt, but it's been deflected by Jupiter's gravity and turned into a short period comet.
Oh, I see. All right.
Okay, this is seems like everything's happening in this part of the sky.
Mhm.
So while let's see, M30's there, the
Mhm.
comet is headed down here.
Mhm.
Over here, we have a planetary nebula that's a good object for the dark, dark skies that we'll be having because the moon is essentially new moon. So we have a dark sky. It's in the near the densest part of our Milky Way down here in Sagittarius. But up here is NGC 6818, which is also called the Little Gem planetary nebula, and it's also called the Green Mars Nebula.
Little gem. Would that be an emerald?
Yeah.
This shows the green Mars here, and this shows a close-up of that around there. So this is a finder chart. I used to make these charts for myself, wide angle shot and narrow shot with roughly a 1 degree field of view, because I would put my telescope in this region, then I'd find this region through star hopping. I'd find it actually in the center, and then I'd set that up, and then I'd change from an eyepiece to a camera. And that was the best way of finding something that I just saw in a catalog, but I didn't want to take the time to put in right ascension and declination into the hand pad. And so this gives a nice NGC 6822 is up there too.
So that's Barnard's galaxy.
Correct. Barnard's galaxy right there. Good memory. And here is that constellation. Looks like a bikini bottom.
Tim or Tom, any comments?
No, that's Capricorn.
Yeah.
Mhm.
Yeah, Capricorn is right there.
Well, the helix is off to the left. That's another one we saw on a previous chart that's nearby.
Yeah, Saturn Nebula is up here.
And that one, I don't think I've searched for it, but I've never seen it. The Saturn Nebula. I want to look at that.
Yeah, here, Ron, here's a little trivia. Do you see the stars in Aquarius there that start with the word Sod? Sod.
S-O-D?
Sod al-Melik, that's the lucky king. Sod al-Suud it has to do with luck. I know that. Sod.
Luck.
Interesting. Arabic root.
They had words for luck back then. Sod.
Sod, yeah, Melik is king. It could mean an angel too. I think Malik is angel in Arabic.
Well, they owned
The
it.
sky. Beautiful part of the sky.
Yeah.
Yeah.
Well, that's a lot of stuff in those big round circles.
Is that the little gem right there?
Yeah.
This is the Green Mars,
Wow.
also known as 6818.
Okay.
What's the diameter we're looking at here? Miles or
No.
Oh no.
not miles? Okay, feet.
Light years.
These are about 25 seconds of an arc.
Mhm.
The planetary nebula itself is about 48 seconds of an arc, but you can't see that. Goes way out here. What you see in the scope visually is 25 seconds of an arc. That's about the size that Mars is at the best you'll ever see Mars in its close approach.
Ronnie, you'd have to know the distance to figure out how big across this is, but it's going to be approaching light years in size, not miles.
And there's stars inside this?
Just the central white dwarf there, that little sort of very green dot. Yeah.
So it's a planetary, Chuck, right?
Yes.
So this nebula is the aftermath of a nova?
No. Just a dying star like our sun's going to do.
Okay, but
Just
what are we
pops
looking
off
at?
its outer layers.
The white ball itself is mostly dust and gas,
Yes.
Yes.
and it's light years across.
Well, probably not light years, but on the order of a light year.
Yeah.
And lots of water in it.
Okay, little gem, huh?
That's also a good variety of lettuce, little gems. I grow those.
And you explained, and I probably missed why it's green.
Oxygen.
Probably oxygen 3, my guess.
Yeah, this would really stand out in an O3 filter. That's how you one of the ways you discriminate between stars and planetary nebulas. Because if you're not real careful and you're looking for it by scanning your scope, you'll go right over a planetary nebula thinking it was a star. But if you had a higher powered eyepiece, you'd see that it's more of a disk. But then you have a narrow field of view, so you'd miss it.
Yeah, and
Really?
the
It's
Ron
one of
they did.
nature's little joke on us.
Yeah, I was going to say to Ron, even though it's called oxygen 3, it's 2 times ionized oxygen. That's just the nomenclature. So oxygen has lost 2 of its outer electrons.
Well, did I not hear that if oxygen is seen in the spectrograph of an exoplanet's atmosphere, that means life was there creating it?
No,
No,
Uh-uh.
I didn't
it
hear
means
that.
if you see oxygen and methane together,
Yeah.
then something has to be actively producing those components in a planetary atmosphere. A planetary nebula is not a planetary atmosphere.
Would it be safe to say that most of the oxygen in the universe is probably combined with hydrogen as water?
A lot of it is. I don't know about most.
Yeah.
There's certainly a lot of hydrogen out there all by itself.
How about CO2? There's a lot of that too, isn't
There's
there?
a lot of that too.
Mm-hmm.
CO2 seems to be the common starting atmosphere, it looks like from what I read.
You know,
Venus sure has more than its share of it. Mars has a little trace of it. It's the dominant thing. Somehow we lost all of ours due to a biological activity, plant life.
Oxygen is 8, carbon is 6, and there's a lot of that.
Yeah.
And on nitrogen 7.
Nitrogen is in between.
Yeah,
Maybe.
CNO. Easy to memorize. Remember.
Amazing.
Ooh, look at that field.
This is what's called Caldwell 16
Mhm.
or NGC 7243.
Not a cluster?
It's an open
Yeah.
cluster.
It's open.
Oh, is it?
Pretty sparse, but nice. It's real pretty.
Hmm.
Yeah, a lot of blue stars there. Pretty hot.
Okay, I got two charts reversed. This one should have gone first.
Okay.
This is the finder scope for that open cluster.
Aha.
This is 1 in the morning, and the horizon is not in view.
Right. It's high in the sky, Jerry.
Yep.
Yep.
Cassiopeia, Andromeda, the great galaxy in Andromeda, the Cygnus with the North American Nebula up here.
Wow.
This is a region, this is where it's a sparse open cluster. These brighter stars and these red stars are members of it. It was a short while ago, it was a nebula, but these stars became stars and they blew all the nebula dust away. This nebula is estimated to be 100 million years old, which is very young for a cluster.
Yeah.
I looked all over the internet trying to find a Hertzsprung-Russell diagram for this, but it's not well studied that way. So what you would have seen was a main, what is it? The main
Sequence.
Yeah.
sequence. Thank you. The main sequence goes up, and it pretty much goes up undisturbed because it's got a lot of its hot stars are still burning. They haven't run out of their fusion products.
Yeah.
But it's a beautiful cluster.
It'd be part of ZAMS, right, Jerry? ZAMS, zero age main sequence.
Yeah, that's true.
Yeah. It's a beauty.
Mm-hmm.
So all those stars are orbiting each other, sort of.
No, they're
I
not.
wouldn't say so.
They're each orbiting the center of the galaxy. And because they're in different orbits, their speeds are slightly different. And that causes the cluster to slowly disperse.
Huh.
If they were close enough and tight enough, that then they could have a common gravity would hold them together, and they'd be a globular cluster.
Yeah.
Ah, there you go.
But they still have some, slight gravitational
That's right.
attraction to each other here. So that's kind of keeping them as a group that's gradually expanding.
Yeah, and when the globular cluster loses their stars slowly, it's called a stream of stars. And you can find those, they're famous, and you can find them in larger scopes, see them around the sky.
So do you think those golden stars belong to it too, Jerry?
I think so. It says in there,
So they're aging more quickly, huh? Because they're more massive.
They are cooler surface temperatures,
Mm-hmm.
so they're bigger. It consists mainly of white and blue stars
Yeah.
against the background of yellow and red stars. So I guess they're considering the red stars of background stars.
Yeah.
And
So
maybe a lot of the smaller ones there look reddish too because there's a lot of dust in that area.
yeah, yeah.
Do you know what the collective magnitude is, Jerry, for this group? Just curious what it would look like in a smaller telescope.
It was like 8 or 9.
It's
Oh,
eight.
that's good.
It's 21 arc seconds in diameter and it's magnitude 8.
Okay. That's really pretty.
Oh, wait a minute. Correction.
Mm-hmm.
Caldwell 16 shining at magnitude 6.4.
Yeah. Yeah. The Caldwell objects tend to be fairly bright.
Yeah, it's Alpha Lacertae
Okay.
that is shining at
Well, that's 3.8.
yeah, its brightest star is right in the center of the cluster, and it's shining at magnitude 8.
Okay, that's the 8.
Okay. Okay.
Yeah, it's very nice.
Oh, it's beautiful. Yeah.
Okay, now here's a
Love
hard
the colors. Love the colors.
Yeah.
Yeah.
Now
Okay.
there's a solar eclipse going on soon.
North Atlantic.
Yeah, but not for us.
Not for us.
Sean Kelly of Santa Barbara City College is apparently in this region down here of Spain watching it.
I see.
So,
Yeah, and Isla and the museum's going to have a kind of like live broadcast of this from a scope in Spain.
oh, okay.
Wednesday morning, I think they're kicking it off around 10:30, and it goes to 12:30. And I think she said yesterday that they're going to have kiddie activities before it. It's at not Farron, the other one,
Fleischmann.
Fleischmann. Yeah, the big hall.
Oh, very nice.
Yeah.
We can go in there and watch it for free.
That's right. We were thinking about checking it out.
Mhm.
Will the rest of us get a partial?
No.
Oh, no,
not that far
no.
away. But on the moon is new at that point,
Mm-hmm.
and in 2 weeks after this, on August 27th, there will be a 96% partial lunar eclipse,
Mm-hmm.
which we will see around full moon.
And
So we're not completely being passed by the eclipse eye.
Iceland's right in the middle of it, isn't it? Look at that.
Yeah.
Well,
And you see, Ron, the extent gets thinner and thinner as you go towards Spain.
Mm-hmm. Yeah, this is a short one. The moon is really moving. It's only 2 minutes long, 2 minutes and some
Wow.
seconds.
Okay.
and it's a sunset eclipse for
Yeah, I was going to say it must be deep in the day.
Yeah.
If we're seeing it around 10:30 to 12:30, yeah.
And the track is north to south.
No. Well,
It's coming right by Reykjavik in Iceland.
yeah, it's actually kind of west to east. This is a flat projection here.
Mm-hmm.
Huh. It looks north to south to me.
Yeah, I think say Nova Scotia off to the left there.
Yeah.
Yeah.
There.
Yeah.
Yeah, right in there. Mm-hmm.
Mm-hmm. Okay.
That's a beautiful path.
Anyway, we've also got a August 13, so that is Thursday.
Mm-hmm.
Looking northeast
Yep.
at 4 a.m. You always want to look at meteor showers between midnight and dawn, because that way you're looking out through the Earth's windshield in a rainstorm. You always see them the best that way. So you look, they'll appear to come from here. If you see one in here, all you'd see is something get bright and then disappear. And the ones with the longest tail will be the farther away from the radiant.
Yeah.
So you want to look 40 to 60 degrees up across the sky. And the most important piece of equipment that you need is a fluffy chaise lounge.
Yeah. Yeah,
Huh.
Jerry listed that as his observing equipment.
Yeah.
Did we miss the lizard?
Did we what?
I don't recall you saying the word lizard. That are we
That's
yet?
Lacerta. Lacerta's the lizard.
Yeah, great lizard in the sky, Lacerta constellation. Did we miss that, or I just didn't
It's
hear it?
not all that great, but
Yeah,
yeah.
it's kind of a small constellation, but
If
made the
that's something
88.
around Cygnus, it should show.
Yes.
Okay, so we had it on.
Yeah, it's
Well,
kind
I
of
just titled that section. It doesn't mean, let's see, oops.
Yeah, you had it in there, Jerry.
Yeah. I just
Well, is there a lizard picture on the ceiling of the
Yes,
planetarium?
yes,
Mhm,
yes.
mhm, mhm.
It doesn't look like a lizard. It looks like
This was the lizard. Okay, I'm
No,
sorry.
this isn't the lizard.
Oh,
the
this
lizard
isn't
is the
lizard.
constellation that this is in.
Yes.
Oh,
See
There it
right
is.
here.
There's Lacerta.
There it is, see.
and that means lizard in Arabic?
No, it's
Oh,
Latin.
it's
It's Latin.
Latin.
We learned it's Lacerta.
Oh, okay.
Yeah, Church Latin.
Lizards are pretty much worldwide, aren't they? They're on all the continents.
Yeah, I'm watching some right now out of the window here.
Not Antarctica.
We have spurts of eggs that hatch out here, and you get a lot, like dozens of little teeny lizards.
Aren't they neat?
I
Yeah.
like them, yeah.
Yeah.
When I was little, I tried to catch them. Now I wave to them and let them alone.
We
Yeah.
have lots of crows out here, and they tend to feed on the lizards.
Of course,
Yeah.
So,
the only descendants of the dinosaurs that have a little,
no, they're pre-dinosaurs. They're reptiles.
I
The
know they're
descendants of
reptiles.
the dinosaurs are birds.
Yeah.
You always wondered what a Tyrannosaurus would taste like. It tastes like chicken.
Chicken.
But the lizards survived the big rock from space by being underground, you suppose?
I don't know how they made it, but
Mhm.
they did.
I love it.
They were
Well,
under a
all I
rock,
got
but it
here-
wasn't the rock.
Mhm.
Well, I guess all our mammal friends and grandparents were under rocks.
Yeah.
Are we done? A little early?
3 minutes.
Where are we going to be, Chuck?
Anyone know any good jokes?
No, obviously. Where are we going to be? We're going to be Wednesday night at El Capitan, not El Capitan, at Carpinteria State Beach for the meteor shower. Although that's fog bait down there. And then on Friday we're at Refugio.
Ran into
Refugio
some-
is going to be good.
Yeah, let's
yeah,
hope.
somebody I ran into at the Star Party said he met you for the first time at Refugio and was thinking of joining the club. Did you meet him, Tim? I think was his name. Grizzled little guy, skinny dude, came up to me and just loves us, but isn't joined us yet. But
Oh, I don't know who that is.
all right, well, let's get together on the screen next week. Again, we'll be back on program number 286 of the Astro Hour next week. In the meantime, keep reaching for the stars. How do we say goodbye here? There's a special way.
Hasta Nebula.
Live long and prosper.
Nebula, everybody, on behalf of the